Hello and welcome to CodeBlaze, and today I'll be starting a new tutorial series and we will be creating voxel chunks or Minecraft like terrain in Unity using the new job system and the burst compiler. So this series would be mostly focused towards the mesh building part and how that can be optimized using the job system and the burst compiler. So it's kind of a tutorial for the new job system also, like you could consider it learning by example. So the end result would be something like this. You would have this chunk component that you can add to any game object, and you can have multiple game objects. So each chunk is a 16 by 16 by 16 chunk. So I have 4 chunks here, and if I just press the play button, and you'll see these chunks are generated pretty much. And what we'll be doing would be simple mesh building. It wouldn't be any greedy meshing or something like that, but still you won't have any hidden faces inside except for the chunk borders, and even those can be removed if you are creating a proper voxel engine. But I want to keep this series limited to the mesh building and the job system part only, to like show you how those are used, and the new Unity collections and the mathematics library, and how the native containers are used to create this basically this generation. It's pretty fast. It's actually faster than if you do it default, since each chunk is now generated on a separate thread. And that's the end result that you'll see. Next, I'll be creating a simple blank HDRP project. You can use any of the 3D templates, the default or the URP, it's up to you. And we'll be installing a few packages, mainly the jobs and the burst compiler, along with mathematics and the collections package. So here I have Unity 2020.1 beta open, and I've just created a brand new project using the HDRP template. You can use any of the 3D templates that you like, URP or the default one, anyone will work fine. And I went ahead and installed the jobs in the burst package. And I'll just show you the versions. And one thing, if you are using Unity 2020.1 and if you want to use preview packages, you need to go to your project settings and inside package manager, and here you'll need to tick this checkbox which states enable preview packages, and with that you can go ahead and install the jobs package. The latest version at the time of the recording is 0.2.10 preview 12. And with this you will get the mathematics and the collections package version 1.1.0 and the collections package 0.9 preview 6. And other than this I have the burst compiler package installed version 1.3.3. As you can see, the jobs and the collections packages are still in the preview and their API may change. So I'll try my best to rectify any of the breaking changes down below in the comments or the description. But if you want to follow this tutorial completely, I'll recommend you use these same package versions. And back in the scene, I just deleted the example assets, and it's totally the same scene that we have here. So next thing you can do is you open your code editor, and we'll start creating a basic block class. So that's the target for this video, your basic project setup, and get our blocks data also set up so that we can continue on with the generation. So in the scripts folder, I'll create a new directory called blocks, and I'll create a new C# file called blocks. I want the B to be capital. Okay, and we'll get rid of the class since we need an enum here, and this will extend from ushort. Now you can extend from a smaller data type, and I'll tell you the reason why I'm extending it from ushort and not using the default int value. So each of our chunks will have a blocks array which will contain the different blocks that chunk has, and that array will be of length 4096 since we are creating 16 by 16 by 16 chunks. So if we use integer as the base type of our blocks, and then first of all we are not using the full length of the integers anyway, since we will only have a few different types of blocks in our system. So we can use a smaller data type and save a lot of memory on per chunk basis. So that's why I'm going for ushort. You can even go for something more smaller than this, like ubyte or something, but it all depends upon the number of blocks number of different types of blocks you want to have in your voxel system. So for now we'll create 3 different blocks. The null block, which will be the default block. The blocks array will be initialized to, so this will be ox00. Next we'll create the air block. So this will for now represent the transparent block in our voxel system, and then we'll have a stone block. This will represent an opaque block in our voxel system. Once we implement a proper texture atlas, we'll add more blocks so that we can have different textures on different blocks, but for now we'll have these 3 blocks. Next we'll create another enum called direction. Again, this enum will only be used with the blocks, so each of this direction will represent one of the block faces. So we have 6 directions. These directions are the same as the vector 3 directions that we have. So we have the forward, right, back, left, up and down, and this is something that will just make the code more readable. You can use 1 2 3 4 5 6 also for the corresponding directions. It's up to you. Next we'll create the block data structure. So this structure will contain the basic data required to create a cube. So public struct block data. Now why I'm creating this as a struct rather than a class is something that will be more clear once we get into the job system part. So for now just bear with it and create a structure. And for now we'll define 2 things here, the vertex array and the triangles array of a default cube. So we'll say public static read only vector 3 array called vertices, and we'll initialize this. I'll just copy over the data here, and needs to be vector 3. Okay. Next we'll have our triangles array, which is again something that I'll copy over. So triangles array will be a 2D array of integers, and with that we have all our block data required for generation in here. So I'll basically explain from where I got this data. So if you export the default cube of Blender or any other 3D package as an obj file and then open that file in any text editor, you will basically get the vertex and the triangles and the UV and all the normals array, and from that you can get this data. Now your data may be different depending upon the scale and the position of the cube, but this is something that I got. So these are the vertex array is of length 8, which represent the 8 different vertices of a cube, and the triangles 2D array, the top level array is of length 6 and the internal arrays are of length 4. So the 6 length array represents the 6 faces and the internal arrays represents the 4 points in each of those faces. So basically if we get the direction up, so that we want to create the face that points up, we'll basically see which of the face it corresponds to, and from here we'll get 4 numbers, and we'll use these 4 numbers to query the vertex array to get 4 vertex positions, and that's how we'll be generating our cubes. Now if you need more information regarding Unity runtime mesh generation and more information on how this data works, I'll link down below a great playlist which goes over runtime mesh generation in Unity and also the basic anatomy of a cube. That will really help you out, so I suggest you go and watch that. But for now we have basically set up a project and done everything from the basic block setup, so that we can now use this data and create our voxel worlds. So that's it for this episode, and from in the next episode we'll be creating basic cubes, and after that we'll go over the basics of the job system, and let's see how long the series goes. Even I don't know how many episodes would be created, but I have a few plans for this series, and it's a really big step for me. So thanks for watching. If you have any suggestions, please leave them down below in the comments, and subscribe for the upcoming videos. Thank you.